There is a 7-meter iron pillar standing in the open air in Delhi. It has stood there, exposed to rain and sun and monsoon and dust, for 1,600 years. It weighs 6 tons. It is wrought iron, hand-forged, hammer-welded from hundreds of pieces. And by every rule of chemistry we know, it should have corroded into a pile of orange dust centuries ago. Modern structural steel rusts through in decades. Cast iron corrodes in a human lifetime. But this pillar, built during the reign of emperors whose dynasties are extinct, whose language is no longer spoken on the street, stands black and intact, its surface barely touched. For 1,000 years, metallurgists have stared at it and asked the same question. What did they know that we forgot? This is the story of an object that should not exist, and the modern science that finally explained why it does. The Iron Pillar of Delhi stands in the courtyard of the Qutb complex, in the shadow of a 13th-century victory tower built by Muslim conquerors. But the pillar is older, much older. It is 7.2 meters tall, 6.1 tons of solid wrought iron. The top is crowned with a decorative capital, a lotus bloom, corroded away by time but still recognizable. The bottom sinks 2 meters into the earth, anchoring it. And on one face, about a meter from the ground, there is an inscription, 6 lines of text, carved in Sanskrit, in a script called Brahmi. The inscription is a eulogy. It praises a king it calls Chandra, a ruler so powerful that his enemies fell before him like waves breaking on a shore. Historians are nearly certain this is Chandragupta II, one of the greatest emperors of the Gupta dynasty, who ruled northern India from around 380 to 415 AD. The Guptas were the architects of India's golden age. They gave the world the concept of zero, the decimal system, advanced astronomy. And apparently, they could do something with iron that no one else on Earth had managed. Because wrought iron at this scale does not come from a mold. You cannot cast it. Wrought iron is forged, heated white-hot and hammer-welded, piece by piece, bloom by bloom, until the parts fuse into a single mass. Metallurgists estimate the pillar was built from at least 200 individual blooms of iron, each one forged, shaped, and welded to its neighbor while the metal was still soft enough to bond. The whole pillar would have been worked as one continuous forging session, because if it cooled too much, the welds would fail. And when you look at the surface today, you cannot see the seams. The pillar is one object, molecularly fused, forged by a team of smiths whose names we do not know, working with tools and techniques we can only guess at. But the real mystery is not how they built it. The mystery is why, 16 centuries later, it still looks like this. Iron rusts. That is not opinion. That is thermodynamics. Expose iron to oxygen and water, and it oxidizes. It becomes iron oxide, the red-brown powder we call rust. The process is relentless. It is why we coat steel and paint, why ships are scraped and recoated every few years, why bridges are engineering nightmares of maintenance. Modern structural steel, exposed to weather, can lose structural integrity in 30 to 50 years. Ancient iron, forged by hand, full of impurities, porous, should corrode faster. The Iron Pillar of Delhi has stood in open air since roughly 400 AD, 1600 monsoons, 1600 dry seasons, 1600 cycles of rain and heat and dust, and it is almost pristine. There is rust. If you look closely, you can see thin patches of corrosion, mostly near the base where moisture lingers. But the pillar has lost, at most, a few millimeters of its original thickness. At the current rate of decay, metallurgists estimate it could stand for several thousand more years. For centuries, no one could explain it. British engineers in the colonial era measured it, photographed it, published papers speculating on coatings, on secret alloys, on atmospheric quirks. Some suggested the Guptas had discovered stainless steel a millennium before Europe. Others thought the pillar had been coated in something lost to time. In 1961, a metallurgist named Bal Raj Varma analyzed samples and found no evidence of any protective coating. No paint, no oil, no deliberate surface treatment. The pillar was just iron. Purer than medieval European iron, yes, but still just iron. And yet it did not rust, which meant something about the iron itself, its composition, its structure, something locked into the metal 16 centuries ago, was protecting it. The question was what? And the answer would not come from history. It would come from a laboratory in the year 2002. In the late 1990s, a materials scientist named R. Balasubramaniam at the Indian Institute of Technology in Kanpur started looking at the pillar with modern analytical tools. He took samples. He ran electron microscopy. He mapped the surface chemistry atom by atom. And he found something no one had noticed before. The entire surface of the pillar is covered in a microscopically thin layer, about 1/20th of a millimeter thick, of a compound called iron hydrogen phosphate. The material is sometimes called Misa white, after the Mysore region where similar compounds were first identified. It is not rust. It is not iron oxide. It is a passive protective layer, and it forms because the ancient iron contains something modern steel does not. Phosphorus, around 1% by weight. That is 10 to 50 times more phosphorus than you will find in modern steel. In modern metallurgy, phosphorus is an impurity. We remove it because it makes steel brittle. But in ancient forging, phosphorus came along for the ride, a byproduct of smelting iron or with charcoal and no lime flux to draw impurities away. The Gupta smiths were not trying to add phosphorus. They were just working with the iron their process produced. But that phosphorus, combined with 1,600 years of slow weathering, did something remarkable. When the pillar was first erected, the surface began to corrode, slowly. Iron, oxygen, water. But as it corroded, the phosphorus in the metal reacted with moisture and formed iron hydrogen phosphate. The layer built up, molecule by molecule, year by year, until it sealed the surface. And once that seal formed, it stopped the rust. Oxygen and water cannot penetrate it fast enough to corrode the iron underneath. The layer is self-repairing. If it chips, new phosphate forms in the gap. The pillar is protected by its own weathering. Balasubramaniam published his findings in 2002 in the journal Current Science. The title was Direct, a new hypothesis on the corrosion resistance of the iron pillar. He showed that the resistance was not magic. It was chemistry, ancient, accidental, perfect chemistry. But chemistry alone was not enough. Because phosphorus-rich iron exists in other places, medieval bloomery iron, ancient Chinese forgings, and most of it has rusted away. The second factor is climate. Delhi is dry. It gets monsoon rains from July to September, but the rest of the year the air is arid. The pillar spends most of its time dry, which slows corrosion to a crawl. Wet it constantly, and even the phosphate layer would eventually fail. So the pillar survives because of two things. The iron the Guptas happened to forge, full of phosphorus they did not plan for, and the place they put it, a city dry enough that the protective layer had time to form and hold. It is not a miracle. It is an accident that worked. The iron pillar is proof that ancient ironworkers understood their material on a level we have only recently started to match. Not through chemistry. They had no periodic table, no spectrometers, but through empirical mastery. They knew what worked. Archaeologists have found evidence of sophisticated iron production across the Gupta Empire. Furnaces that could sustain temperatures above 1200 degrees Celsius. Forging techniques that could weld blooms weighing hundreds of kilograms. Production at scales that rival early European blast furnaces, except the Guptas did it 1,000 years earlier. The pillar is not the only example. There are references in Sanskrit texts to massive iron beams used in construction, to ironclad war elephants, to chains and tools and weapons forged at scales that historians once dismissed as exaggeration. The pillar proves those accounts were real. If you can forge a 6-ton pillar, you can forge an iron beam. If you can weld 200 blooms into one continuous shaft, you can make armor plate. But the knowledge that built it did not survive. By the time the Mughals ruled Delhi in the 16th century, no one in India was forging iron at this scale anymore. The techniques had been lost, replaced by smaller-scale bloomery work and, eventually, imported European steel. The pillar became a relic, a curiosity. For centuries, visitors came to see it not because they understood what it was, but because they heard it did not rust and they wanted to test the legend themselves. There is a superstition that if you stand with your back to the pillar and reach your arms behind you and clasp your hands around it, your wish will come true. You cannot do that anymore. Too much handling was wearing grooves into the metal. The pillar is now fenced off, but you can still see the polished patches on the surface, smooth from 1,000 years of hands. And you can see something else. The pillar is not perfectly straight. If you sight along its length, there is a very slight curve, a bend introduced during forging, or perhaps from settling over the centuries. It is almost invisible, but it is a reminder that this was not poured from a mold. It was made by people, with hammers and fire and sweat, raising an object so far beyond the capability of their time that we are still studying it 1600 years later. The iron pillar did something unexpected. It changed modern metallurgy. In the decades after Balasubramaniam published his findings, material scientists started looking at phosphorus not as an impurity to remove, but as a tool. If a thin phosphate layer could protect ancient iron for 16 centuries, could you engineer modern steel to do the same thing? The answer is yes. Modern weathering steels, sometimes called corroded steel, are designed to form a stable rust layer that protects the metal underneath. They are used in bridges, in sculpture, in buildings where maintenance is expensive or impossible. The rust is the coating. The principle is older than we thought. The Guptas were doing it in 400 AD without knowing the chemistry, and studying their work has informed modern phosphoric steel alloys, which are now used in applications where long-term corrosion resistance matters more than pristine appearance. But the deeper legacy is what the pillar forces us to confront. We like to think of technological progress as a steady climb, that each generation builds on the last, that knowledge only moves forward. The iron pillar is a monument to the opposite. It is proof that a civilization can reach a peak of technical mastery, build something extraordinary, and then lose the knowledge so completely that their descendants cannot replicate it. The men who forged this pillar could do something we did not relearn how to do until the 19th century: forge wrought iron at multi-ton scales with structural integrity across every weld. They built it, raised it, inscribed it, and walked away. And for 1,000 years, no one remembered how. It stood through the collapse of the Gupta Empire, through invasions, through dynasties rising and falling, through the arrival of new religions and languages and powers. It stood while the knowledge that made it possible faded into legend. The inscription says the pillar was raised in honor of the god Vishnu, as an offering by a king whose fame had spread to the edges of the known world. It does not say who forged it, or how, or why they thought this particular piece of iron would last. But it did last, and now, 16 centuries later, it is teaching us things we thought we invented. The Iron Pillar of Delhi is not just a relic. It is a message, written in metal, from people we will never meet. It says, we knew things, we built things, and you forgot. And the question it leaves you with is this: what are we building right now that someone 1,600 years from now will find in the ruins and refuse to believe we ever understood? If that bent your sense of what the ancient world could do, this next one will break it completely.